There we go. All right. So let's quickly go over our typical whiteboard. 2.6 due the 25th, which is obviously today. 2.7 is going to be due on the 30th. We will finish 2.8 today, so we're going to have that due on the 1st. Again, we said last time we basically finished 2.8. We finished enough to be able to go ahead and say that the test was a week from last class's date, which is why test 2 is going to be covered on the 29th and 30th, which is the upcoming Monday and Tuesday. So you have the day before next class as well as the day of next class. If the only free time you have is during class time, then you can always catch the YouTube replay, but I would highly advise, if possible, to take the test outside of normal class time and then catch us for the live lecture. But either is fine, whatever you have to do to get everything completed, of course. Remember, there is a review available under the homework list, immediately under section 2.8's homework. The review material will help you study for the test, as well as having done the homework and take your notes and watch the videos will help you do well on the test. 20 questions, 2 hours. The test will be in the quizzes and test section. You will only see it those 2 dates. Remember that you must submit your work in Canvas. You must submit your work in Canvas within 15 minutes, or I reserve the right to give you a 0 on the test. We don't want to have to do that. And then that also enables you to email me and say, hey, Mr. Beckner, check out questions 3 and 17. I think I deserve some partial credit. You can explain why, or you can just send me on the hunt, and then that's okay. Remember, this is a no calculator test. This is the last no calculator test. So again, test 1 and test 2 are supposed to be no calculator. Test 3, test 4, the final exam, you'll be allowed calculators for those, because we're going to get into some stuff that it'll be really, really helpful to have a graphing calculator to push us in the right direction, but we're still not using that calculator to do everything for us, which is again why I emphasize showing your work on the tests. Especially once we hit the calculator allowed tests, you're really going to have to make sure you've got all the details in your work, because that's a case where if I see answers, but then I go and check your work, I can take all your credit away for not showing your work because I can go, they let the calculator do everything. But that will be a story for another day. Let's go ahead and pick up where we left off in 2.8. We just have that one pair of problems left. I think it's example 4, A and B. It's going to be relating to the circle, just approaching it from the opposite direction.
I won't read that. That'll be okay. X minus 3 squared. Then plus y plus 4 squared equals 9. So we are identifying the radius, finding the center, and then later we're going to draw it. Those are our 3 goals for this problem. So the center is based on the numbers inside of the x squared and the y squared. Those are the numbers that determine the center. But you have to be very careful. If you think the center is -3, 4, if you thought that was the center, spoilers, you're going to be wrong. Now you might say, oh, well, were you supposed to swap the 4 and the 3? And that would also be wrong. Why is it not -3 and +4? Let's go back and look at the formula for the equation of a circle, this thing. So here is why it wouldn't just be a -3 and a +4, because of these signs right here. Remember when we were doing shifting earlier in this chapter, where the horizontal shifts were backwards? Like if you saw a minus, that meant to shift right, and a plus meant to shift left. That is exactly what's going on here. This is exactly the same scenario. So a minus and then a number says that the center is actually the opposite of the number seen. So if you see a -2, then you would use a +2 for that coordinate. If you see an x plus 2, that means the value of the coordinate would actually be a -2. So you're going to take the opposite of the signs that you see. And this is going to be a common theme. I mentioned that when we talked about shifting, that was going to pop up again. So here's the first time it pops up again, and it'll happen again. So the center here is not -3, +4. It's actually +3, -4. You're taking the opposite of these because it's like x minus h, so the 3 is the h, and then this is the y minus k, but because that's a plus, the k has to be negative, because then you have a minus and negative, and it fixes everything. Then for our radius, and I know I said radius first, but nobody cares what order you give it. The radius is not just 9. If you say 9, that would be wrong. It involves the 9, but remember that that formula, the number it equal to, was the radius squared. So again, it's not 9. It's actually the square root of that number, the square root of 9, because this is supposed to be r squared. So to figure out r, you take a square root. Now you might be saying, well, Mr. Beckner, don't you take a plus or minus square root? That is true, except we're dealing with geometry. You can't have a negative radius, so we throw that out. So yes, technically you would do a plus or minus, but because we're talking about the radius of a circle that cannot be negative, then you don't take the negative. So it's just 3, not plus or minus 3, just a regular old positive 3. And with these 2 bits of information, we can draw our circle. Now, doing this in my math lab is, I don't know, kind of easy, but by hand, slightly more challenging. So 3, -4. So we're going to make a right-sided and down-sided heavy graph. Right, 1, 2, 3, then down 1, 2, 3, 4. Now this point right here is my center of my circle at 3, -4. That's right 3, down 4. That's our center. I'm going to write a little C for center. Here's the thing about the center of a circle. It's not actually a point on the curve. This is an imaginary point. This is more of just a reference than the actual circle. So I'm going to do the circle itself in blue, but a little better than that. I don't want to just randomly draw a circle because it's supposed to have a specific width, diameter, circumference, radius, all these things. And that radius is 3, which would make the diameter 6. And then the circumference would be 6 pi, but we don't need all that. So I kind of detailed this last class really, really quickly. But what you should do is just from the center, go up 3, mark a point. Go left 3, mark a point. Go right 3, go down 3, mark those points, and then just draw a center using those 4 points. So from here, from a height of -4, if I go up 3, see, I'm not going to go to a height of 3. I'm not going to go here. That would be wrong. You go up 3. So 1, 2, 3. And I'm not saying all those are points. I'm just demonstrating that this is where we go because we go up 1, 2, 3 to get there. So there is a point on the circle at 3, -1. Then you would go down 3 and left 3 and right 3. Now, not from that point, from the center. So left 3, 1, 2, 3, puts us on the y-axis. I'm going to need to label some more numbers on my x-axis. 4, 5, 6, -5, -6, -7, because I got to go 3 each direction. So from x equals 3, we go right to 4, 5, 6. And then from y equals -4, we go down 3 to -5, -6, -7. Kind of looks like I just made something I would want a plus sign out of. No, that's not what you do. You just make a circle smoothly as you can. It might come out looking a little oblique or looking a little elliptical, if you will. But that's okay because we did this by hand and on a blind tablet. That's pretty good for myself. My math lab, all you do is click the center and then with your mouse, you just pull right or left or right to make it bigger or smaller. And then you just try to make sure one of these edges is 3 units away from where the center was. It's another case of my math lab makes it entirely too easy. B, we're going to have parentheses x plus 5 squared, then plus y minus 1 squared equals to 36. So our center, again, you're supposed to be taking opposite values for the h and the k, for the x1 and y1 if you prefer calling them that. So it's not 5, -1. The center is -5, +1. The way you think about it is if you were to put these x and y values in, this parentheses squared would just become 0. If you put -5 plus 5, that's 0. 0 squared is 0. So when you plug in the center of a circle, it should make the parentheses square parts just turn into 0. That's the idea. All right, then the radius. So this is the r squared, which is 36. So we take the square root of 36, and that's just 6. Again, not a plus or minus because you can't have a negative radius. Geometrically, that doesn't make sense. And then we can just draw this up. -5, 1. I need a little more left-sided heavy graph. I'm thinking. Is that going to be okay? Yeah, that should be good. All right, so -5, 1, 1, 2, 3, 4, 5. And I know I'm going to have to go left 6 from that, so I'm just going to mark the -5 and go another 6. -6, -7, -8, -9, -10, -11. And then we'll end up needing a +1. You can figure out those later if you had to. And then from a height of 1, we'll be going up and down 6. So we got to go to 7 and -5. 2, 3, 4, 5, 6, 7. And then 0, -1, -2, -3, -4, -5. So our center is at -5, +1. There's our center, which is not an actual point on the circle. I will do the circle in blue, and these are the actual points on the circle. Go left, right, up, and down 6 from that center. So going left 6 puts us at -11. Then up 6 puts us at a height of 7. Back to the center, going right 6 puts us over at x = 1. Back to the center, go down 6, and that puts us at a height of -5. Again, we don't start back at the origin, we're starting at the center each time. And this was not done nearly as well as last time by hand. It's not terrible. Oh, that's not bad. That's actually pretty good. That's a lot better than I thought I was going to make it. This isn't perfect, but I really can't do much better than that by hand. Remember, you're supposed to be submitting your work for tests. It would be really excellent if you wrote this in your work, because guess what? Maybe on your test in my math lab, you just get a little squirrely with the mouse and you end up pulling your circle just a little too far out. But maybe in your work, I see your center correctly identified. I see your radius correctly identified. You even drew it up appropriately on your work. Then you could say, hey, Mr. Beckner, please take a look at my work. I think my circle is right. I just goofed up when I made it in my math lab. And then I could give you a solid amount of credit, if not all of it, potentially. So showing your work is still critical. Don't think just because you're taking a My Math Lab test that you're not supposed to show your work, because you will never earn yourself partial credit without work with this. All right. So that is that for 2.8. That is that for Chapter 2. We have completed all the material for the test. As I said, I had very little left to cover, only like 10 minutes worth of stuff, which is why I have no problem saying that that test is this Wednesday and Thursday.
Ignore that.
Chapter 3. Section 1, of course. So Chapter 3, we are going to spend our time studying what we call polynomials. Now, we're going to work our way up the polynomial chain, and we've already dealt with polynomials about solving some equations that were polynomials, whether they were quadratic or even higher. We've had factoring, we've had substitution methods. So this chapter, we're going to have a much heavier emphasis on graphing these polynomials. And you might say, well, Mr. Beckner, back in section 2, I want to say 4, maybe 2.5, when I gave you those general shapes of curves, like we had the x squared was this, and the absolute value was this, and the x cubed was this. You go, oh, okay, well, the x squared just points up, points down, and we can shift it left, right, up, and down, all that stuff. That's how we're going to graph all of our quadratics, right? No, that is not how we're going to be graphing quadratics moving forward. And I mentioned that, I stressed that back in Chapter 2, that we weren't really getting a good graph of any of those shapes except maybe the absolute value. We were sketching the graphs because all we were doing was plotting one point and then from that point just drawing a generic shape. But we weren't making sure that that shape was going through any other points. And these curves are more complex. So you really are, if you want a good graph and not just a sketch, you're supposed to find 2 or 3 or 4 points that it goes through. And the more complicated the graph, the more points you need. So you might go, oh, okay, well, Mr. Beckner, if we want to graph quadratics, then just go with like -4, -3, -2, -1, 0, 1, 2, 3, 4 for your x's, find your y's, and then plot all your different points. And I'm going to say, no, that's not how we're doing things in here. We are not just going to use a table of values with random x values or x values being walked up in steps. We are not just going to plot what we call the vertex and then drawing a generic shape from that. We are going to be finding several points, specifically all of the intercepts, the vertex, and then maybe even a couple points after that. So when we're now graphing our parabolas, which remember the generic shape is still, again, before it was just vertex and then plot it up, or vertex and plot it down. This was before. But in order to make this very accurate, what you actually need is 3 points. You would need to know where that point is and maybe where that point is. And they don't have to be symmetric. You could say, all right, well, I've got this point and then I've got this point. But the symmetry just helps. So you need 3 points at a minimum. Let me just, I don't want to use the word minimum because that might confuse you. 3 points at least. You need at least 3 points to graph any parabola, to graph any quadratic. And again, those words are interchangeable. Parabola is the shape of a quadratic. So what is this process? I've already mentioned vertices, intercepts, additional points, symmetry, all these things that can be very, very helpful. All right, so to graph any quadratic function, so anything where it's a polynomial and the biggest exponent you see is a 2. That says it's quadratic. If you see an x to the third, that's cubic. You would not graph it this way. See an x to the fourth, you wouldn't graph it this way. If you see a square root, you don't graph it this way. If you see an absolute value, you don't graph it this way. If you see fractions with variables in the bottom, you don't graph it this way. This is a very, very specific set of instructions for a very specific format. First, determine whether the parabola opens up or down. You can do so based on the sign of A. If A is positive, then it opens up, and if it's negative, it opens down. What am I talking about? What A? I haven't written an A anywhere. Well, that's going to refer to this, what we call in standard or vertex form. Of a quadratic. So this little A that I'm referring to, the function f of x or y, it could be y equals still, is equal to a parentheses x minus h squared, close the parentheses, and then a plus k. Look at this. We got an h and a k. We were just using those letters for the center of a circle. I mentioned that we would be continuing to use those letters. Again, someone could make that an x1 and a y1 if they really, really, really wanted to, but the common notation is h and k for this. So this is not the center of a circle. The vertex is the h comma k. And I'm just going to write this in 2 different spots. The h and the k relate to the vertex, which the vertex is that black point up here. So this, I'm going to do V for vertex, V for vertex. The vertex is either the highest or the lowest point of a parabola. And it is always h comma k when we're using h and k in this manner. So notice this. The h has a minus with it. The k does not. This is the same exact concept as the shifts for horizontal being backwards and vertical. They aren't. That is exactly a one-to-one correlation of events here. This is a minus, whereas this is a plus. So the horizontal shift is backwards, the vertical is not. These are literally literally horizontal and vertical shifts. You start at the origin, and then you can move right H and up K, or left H and down K, whichever is relevant. So again, this is literally the exact same thing as shifting, left, right, up, or down. So inside is horizontal, outside is vertical, horizontal is backwards, vertical is not. So the A, which is the number in front of the parentheses, if it's positive, it opens up. If it's negative, it opens down. That is an exact correlation to whether we have a vertical reflection or not. If there had been a negative outside the core, we said everything reflected vertically. So this is technically nothing new, in fact. All right, so once we know whether it points up or down, you identify the vertex, which we just talked about. That's the H, K, based on the standard form, or also known as vertex form. I prefer the name vertex form because it tells you something that's in there. When you have it in this format, you can tell what the vertex is based on this number and this number. Calling it standard form doesn't tell you anything about it. It's kind of boring. It's extremely confusing too, because later we're going to show you the general form, and standard versus general. Again, you have no reason to know what is in what. I cannot tell you how many times I have swapped what standard form and general form are in my head. I know how to use them. The names don't really matter. The names suck, in my opinion. That's why I prefer the name vertex form for this, because it tells you something you have. So once you've identified the vertex, you can even plot that point. And then you know from that point, you're just either going to go up or you would go down, one or the other, not both. But you wouldn't just draw that again. You need some extra points. That's what steps 3 and 4 are going to do. These two steps right here are going to be in almost everything in chapter 3. Anytime we're graphing in chapter 3, you're going to need to find all of your intercepts. And remember, intercepts are where we cross an axis. So as a reminder, let's say you had some curve that looked like this. This point right here is a y-intercept because that's where it crosses the y-axis. This point right here would be an x-intercept because that's where it crosses the x-axis. You can have multiple x-intercepts. You can only have one y-intercept because then it wouldn't be a function if there were two. But you can have multiple x-intercepts, that's fine. It might not be an invertible function, but that's still okay. So x-intercepts are found by setting the y equal to 0. Remember, the intercept always has a 0 opposite the name. A y-intercept is always 0 comma something because you have to go left or right 0, whereas an x-intercept is always something comma 0 because you go right but then not up or down. You have got to get these two organized, which one is which. It will be critical. You can still get your graphs correct and do great jobs in math without knowing which is actually called which, but there will be homework questions where they say which is the x-intercept and which is the y-intercept. So x-intercept is when the y is 0, y corresponds to f of x. So you just set the function equal to 0 and solve. You might have to factor, you might have to use the quadratic formula or complete the square if you prefer, that's up to you. Once you find all of your x-intercepts, of which there can be more than one, find your y-intercept by just plugging in 0 into the function. And this is pretty easy most of the time. Now I will say, once you've done steps 1 through 4 for these, usually you don't have to do step 5. Usually you don't have to do step 5, which is plot any additional points as needed. The only time you would ever have to do step 5 is if you can't find any intercepts. If you can't find any x-intercept, maybe you only find a y-intercept, then you'd only have 2 points and you need a third. Now, I said to use symmetry if you're able to, which I'll describe later, but you could also just plug in any x value you haven't used. So if your vertex happens at x equals 1 and your intercept was, your y-intercept was at x equals 0, then you could plug in x equals 3 or -5 or 29.5, it wouldn't matter. But again, most problems are done by step 4. Occasionally, you'll need another point and you can use symmetry, which we'll talk about soon. All right. One last thing I just want to type up that I said earlier is that the vertex, the highest point on a parabola. Along with the axis of symmetry, vertical line, the vertical line, x equals h. X equals h is a vertical line. It's vertical because it's x equals a number, and we can tell that whatever the x value of the vertex is what that number would have to be to make it symmetric, because that's where the vertex is going to be located at. Imagine you've got your vertexes right here. Here's your h, comma k. And then you draw your parabola, you got some more accurate points, whatever. Your axis of symmetry, we tend to do as a dotted line, dotted vertical line that splits this in half. AOS for axis of symmetry. So that axis of symmetry says that if you've got a point that's right 3, and that point would be, you know, some number comma some number, you can very easily figure out what this point is because it would have to be left 3. If you go right 3, there's a point. If you go left 3, there's a point from that height. Or maybe up here, if I go left 7, I could go right 7 and find a point as well. That's how an axis of symmetry works. That is very useful to find your additional point, because maybe you have this point to the right and you can say, well, instead of plugging in another x number, let me just mirror it and boom, there's another point. The y-axis is not the mirror, generally speaking. It can be, but it's rare. The axis of symmetry is not one of your original axes. It's this new thing. So you're just putting the mirror wherever it's relevant for the graph. Okay. Trying to decide if I want to do this example first or if I want to do the details. Let's do the details first. So, last thing before an example. There are 3 cases of X-intercepts. There are 3 different cases possible. You could have 2 X-intercepts. Now, it's possible these point down instead. Don't take that as saying it's only possible they go up. It's possible they go down. So it's possible you get 2 X-intercepts like this. And then maybe your vertex is down here, and then your parabola just looks like this. So this is the 2 X-intercept case. It is also possible instead that there's only 1 X-intercept. So maybe it's just sitting on the x-axis, and then from there your graph points up or down, doesn't matter, not the relevant case. Just saying 1 x-intercept looks like this, where it's sitting on the x-axis instead of going through it. The final possible case is that your vertex point might be up here, and it points up, in which case it doesn't cross the x-axis at all. That means there are 0 x-intercepts. I have showed you this picture, showed you? You've seen this picture before, these 3 pictures before, back when we were talking about the discriminant. This directly correlates to the discriminant. When the discriminant was positive, we had 2 x-intercepts, D positive, that's for the discriminant case. When the discriminant was 0, it was 1 x-intercept, and when your discriminant was negative, it was 0 x-intercepts. Now what we said before was it was 2 real solutions, 1 real solution, and 2 complex solutions. And it is this right here that once again emphasizes what it truly means to be an imaginary number. The first 2 cases have real solutions because they cross the x-axis. This third one imaginarily crosses the x-axis. It imaginarily crosses the x-axis. That is the entire reason we call them imaginary numbers, because their solutions have eyes in them, but they don't cross the x-axis. It's imaginary. That is the only reason we call them imaginary numbers. So this is a good idea to understand for you, because when you go to do your graphs, it could either point you in the right direction, or if you start graphing something that disagrees with what your solutions were, then you could say, hold on, I'm making a mistake. Like maybe I start this one and I point it up, but I go, wait a minute, I had two real solutions. That means my graph should point down, and that might be because, oh, I thought the A was positive and it's actually negative. There's my mistake. So this is going to be our goal, and it's really nice to have 3 points. So again, 1, 2, 3. This one would have been perfect. This one, 1, 2, and then what we could do is use symmetry. We can say if this distance is 1, then this distance would be 1, and we can figure out where that point is. Or this one, we'd only have these 2 points, and again, we might need to use symmetry to find that third. Or just plug in a random x value to find a third. So like I said, we usually have enough points because most of the time we're dealing with this case here. This is what we see most of the time, but not all the time. So going back to the instructions, since we're finally about to do some problems, determine whether the graph points up or down based on the sign of A, positive up, negative down. Find the vertex. Be careful because the vertex, the x coordinate is backwards, but the y coordinate is not. Oh man, Mr. Beckner, though, at the center, they were both backwards. Why can't you give me a break? It's not my fault. I can't help it that math is not consistent from one thing to another. It has everything to do with the fact that with a circle, the x and the y are being squared, but with a parabola, they're not. That's why there's inconsistencies there. But again, this correlates to the shifting. After you find your vertex and plot it, you find your x and y-intercepts by just finding where the x is 0 and where the y is 0. But try and remember which name it goes with which one, because that will be important for homework and tests. Then if you need any other points, plot your other points. All right, definitely don't need these notes yet. All right, so we're up to example 1. Why does it keep doing that? Silly computer program. Example 1, graph. A, we're going to have f of x or y, doesn't matter how we write it, equals -2, parentheses, x minus 3 actually, squared, and then a plus 8. We're going to go through all of those steps. And I hope you've written them down because they're not going to be on the screen the whole time. Determine whether it points up or down based on the sign of A. The A is the number in front of your parentheses squared. That's a -2. So that says that A is negative, so it points down. You can write A as negative if you like, and then say points down. Or opens down. Points down, opens down, whatever word choice you like. I prefer opens, but points is fine. Second step, find your vertex, which is that h comma k based on this form, which we are in, thankfully. We're not always in that form. We'll have to deal with that later. So the x coordinate, you change the sign. The y coordinate, you do not. Practice makes perfect. So this -3, you're going to change its sign to a +3. So our vertex would be +3 comma, and then for the k, you do not change the sign of that number, so it's just a +8. This is where people make their simple mistakes. They go -3 comma -8 or -3 comma 8, but it's 3 comma 8. Then we can find our intercepts, so we're up to step 3. And the order you do these things is completely arbitrary. I could do step 4, then step 2, then step 1, then step 3. It does not matter, it's just get them done. So next we're going to find our intercepts. I will do the x-intercepts first to keep it in order. So we're doing x-intercepts. I will not scroll back after this. We'll do y-intercepts next, which is f of 0. X-intercepts are when you set the y equal to 0, you set the function equal to 0, you set the whole thing equal to 0. So our x-intercepts, could be singular, plural, or none, is where we set f of x equal to 0. So we go 0 equals -2 parentheses x minus 3 squared plus 8, not equals 8. Sorry about that. I was looking at the equal sign. And then we solve for x. Now you might say, oh, we'll distribute the -2. That's a terrible idea to do first because exponents come before distributions. You might say, we'll take the x minus 3 times itself and FOIL and then distribute the -2 and then add the 8. That's fine, but you're not going to like the process. Remember that square root property. If you have a parentheses squared, you can isolate it and then do something from there. So let's do that. Let's subtract 8 on both sides, which will give us -8 is equal to -2 parentheses x minus 3 squared. Let's then divide both sides by -2, which will give us +4 equals parentheses x minus 3 squared. And then what we do is we take, is it just the square root, question mark, inflection and voice? Question mark? It is not. That is not what we just do. We are not dealing with geometry here, not a circle. We're dealing with true algebra and graphing, so you cannot forget your plus or minus. That is where people go wrong. Pre-calc 1, pre-calc 2, calculus, differential equations, it doesn't matter. The square root of 4 is 2, so that's a plus or minus 2 on the left side. Then equals the square root and the square cancel, so that's just an x minus 3. And then we're going to add 3 to both sides, remembering to put it in front of the plus or minus for reasons. So we get 3 plus or minus 2 is equal to x. Do not stop here. This is not a valid answer because you can actually do the plus and the minus. Also, we're trying to find intercepts, so we need to label coordinate pairs as our answer. So because this isn't 3 plus square root of 2 or 3 plus 2i, you can add and subtract 2. 3 plus 2 is 5. 3 minus 2 is 1. So that tells us x equals 1 and 5. And if you think this is the answer, you are wrong. You need to make these coordinates. So our x-intercepts, it's not 1, 5. It's 1, 0 and 5, 0. Because intercepts always have a 0 coordinate and the 0 is always opposite the name. And if you don't trust this, plug in 1 to the original function and you'll get 0. 1 minus 3 is -2. -2 squared is +4. 4 times -2 is -8. -8 plus 8 is 0. Boom. Works. Now let's do our y-intercepts. That's where we just find f of 0. We're making the x value 0 this time. So that's -2 times 0 minus 3 squared plus 8, which is -2 times -3 squared plus 8. Do not multiply first. Got to do your exponent first. -3 squared is +9. So that's -2 times 9 plus 8, which is -18 plus 8, which is -10. So f of 0 is equal to -10. So our y-intercept is 0, -10. Write this down if you think it'll help you. You will always have one y-intercept. The x-intercepts could be 0, 1, or 2. It's questionable. It depends on the problem. So we got our vertex. Here's our first point. We got our x-intercepts, second point and third point, and a y-intercept of a fourth point. I have said that you need at least 3 points, so we are golden. Now, you might say, well, Mr. Beckner, since we already had the vertex and the x-intercepts, that was 3 points, couldn't I have just gone on? Probably not, because my math lab is going to want to know what the y-intercept is. They are very, very particular about this. So while you can actually make an accurate graph with just the vertex and the 2 x-intercepts, you will generally need the y-intercept, and that will be important for homework and tests. If you forgot the y-intercept on a test, you would not get full credit. So let's plot those 4 points. Let me just kind of pull this back some. Here's our graph. We need a little more heavier on the negative y-axis, so something like this. All right, so 0, -10. Where was the vertex? 3, 8. I'm gonna need a little more on the y-axis. Let's make that like here. So 3, 8, that's gonna be right 3, 1, 2, 3, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. Here's our vertex, and you could label that with a little V if you really wanted to. It is a point on the parabola. It is the highest or lowest. Because this point's down, it is specifically the highest. Now here's what's cool. I don't even have to identify this part, the A being negative so it opens down. When I plot the vertex and the other 3 points, that's all going to fit the same puzzle. It's just nice to see that to confirm it in case we make any mistakes. Our x-intercepts are the 1, 0 and the 5, 0. Here is right 1, up or down 0. And then we got to go right 5 and up or down 0. So there's our x-intercepts. And again, on a technical level, this would be good enough to make our parabola. However, my math lab and I will want that y-intercept for good practice because not all of them happen to get 2 x-intercepts. So the y-intercept of 0, -10, we just need to go down 10 from the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our y-intercept. Now we can connect them and extend them. And I'm going to zoom in so I can do this a little better. Taking my time. You'll start bending a lot more once you get close to that vertex. Boom. And then what I like to do is I like to put arrows on the ends, signifying that that goes on forever, never, never. Now, I did not ask you to graph specifically the axis of symmetry. I did not ask for the axis of symmetry. However, and I'm not going to ask for it specifically for most of these, but in the homework, sometimes they do. In the homework, sometimes they don't. You have to be on your toes. You have to pay attention. So if the problem, all it said was graph in my math lab, you would not have to do what I'm about to do. If it asks for the axis of symmetry, then you do have to do what I'm about to do. So just in case, if it asks for the axis of symmetry, you would have a spot where you have to write what it is. Now this is critical. We said the axis of symmetry is just a vertical dotted line splitting this bad boy in half, making that mirror. And whatever the vertex is, this 3, 8, whatever its x-coordinate is, by design would have to be the equation of that vertical line. So this point right here was 3, 8, just as a reminder. Let me move a little to the side though. 3, 8. The x value is the 3, so that is what the axis of symmetry has to be. If you just do this, if you just write 3, it's wrong. That is not an equation of a vertical line. You are not demonstrating that you understand it's an equation of a vertical line. X equals makes it a vertical line. And then you would just do dot, 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 dot. And you can make dotted lines in my math lab. Again, you have to pay attention to the instructions. If you put this up there and they didn't ask for it, it'll be marked wrong. Now on a test, that's another thing I can go back and give you credit for if you point it out. But I would not give you full credit for not reading instructions. I would say, well, I'll give you 4 out of 5 points because everything else is perfect, but you gave me something I didn't ask for, and sometimes we don't want TMI. We don't want too much information. But obviously I'm not going to punish you harshly for that. But again, you have to let me know. So what are we going to do? We're going to pay attention. Sometimes the axis of symmetry needs to be drawn and identified. Sometimes it doesn't. So let's just look over what we did again. We found our A. so that we knew whether it was pointing up or down, and our graph even confirmed that it pointed down. As I said, this was an optional step, but it's helpful, and I do suggest doing it. In my math lab may specifically ask you that. We find a vertex because this is in vertex form. It's these numbers that tell us, but you have to be careful with the signs. Then we find our different intercepts. X-intercepts is when we set the whole thing equal to 0, and we did some algebra from another chapter where we did that square root property. This plus or minus square root is never going away. Don't forget it. We got our points. Then we found our y-intercepts by just making the x 0. We got our point. And see, because it's a function, since we're plugging in one value, we can only get one value out of it. These are different x values, so it's okay that they led to the same y value. It would not be an invertible function unless we trim some of it, but it's still a function. And then we just graphed it. We made an axis of symmetry just in case we were asked to. And boom, there's our graph. See, that is much more accurate than just plotting a vertex and trying to guess how wide is it. Is it supposed to be like that? Is it supposed to be like this? Is it supposed to be really wide? I don't know. But by getting those other points, we do know. Now, again, on a technical level, do your points have to be intercepts? No. Someone else could go and say, I'm going to find this point, and then I'm going to find this point, and then they're going to connect it, and they would get the exact same shape. But it's usually easiest to find the intercepts because intercepts involve a 0 somewhere. All right, finally, B. Gonna need lots of space. Oops. Now look at this. I have eraser selected. You can see that. This thing is weird sometimes. B. F of x equals parentheses x plus 4, close it, square it, plus 2. Spoilers, this one is going to be a little more annoying, maybe more challenging than the previous one, but still within our realm of capabilities. Good idea to find the A. The A is positive this time. You might say, well, how do you know that? There's no number in front of it. Well, it means that that's a positive 1 that's right there. If you don't see a number in front of a product, it's positive 1. So since it's positive, it opens up. We can find our vertex based on the numbers being added and subtracted to this thing. We've got a plus 4 and a plus 2. Be careful, the inside is opposite. So that would be a negative 4. The outside is direct, so that would be a positive 2. Again, those subtle details is where people make massive mistakes. But the thing is, when you go to plot your vertex and then you get your intercepts, if you get your vertex wrong, it might be over here, and then it'll say you have x-intercepts here and here, and then you're trying to draw a parabola that looks like this. That is not a parabola. So quite often, when you make a simple sign mistake somewhere, it's going to show because your graph is going to look like nightmare fuel. Next up, let's find the x-intercepts, which is where we set the whole function equal to 0. So we'll go 0 equal to parentheses x plus 4 squared and then plus 2. Now, once again, you can FOIL that, add the 2, factor it, or quadratic formula it, whatever works. It's going to take a lot longer that way, though. Square root property. Solve for the thing being squared. So we subtract 2 on both sides, which will give us negative 2 is equal to parentheses x plus 4 squared. And then we take not just a square root, a plus or minus square root of both sides. We get rid of the parentheses squared. Now we got a square root of a negative, which means we got to pull out an I. So that's plus or minus I square root of 2 equals x plus 4. Final step to solve for x, we subtract 4 on both sides, making sure to put that in front of the plus or minus feature. And that tells us negative 4 plus or minus I radical 2, or I square root of 2, is equal to x. Now, there's a problem here, and it's right there. That's an I, and this was something I mentioned several times just a few minutes ago. We said that your x-intercepts are not real if there's an I. So these are not real, so there are no X-intercepts. The X-intercepts are what is imaginary. That's what we mean by something being imaginary. These numbers exist, they are important, they are critical. It just means this graph doesn't cross an x-axis. Whoop-de-doo. Well, that kind of sucks, doesn't it? There's no x-intercepts in the last problem. When we did the x-intercepts, scrolled up too much, we found 2 of those things. So we already had 3 points by now in the previous problem. For this one, we only have 1 point. We only have the vertex so far. Oh, well, that's a challenge, isn't it? Well, let's see what happens. Let's do the y-intercepts, intercept, which is where we do f of 0. F of 0. So now, here's our function. We just make the x 0. So that's 0 plus 4 being squared, and then a plus 2. Well, that's 4 squared plus 2, which is 16 plus 2, which is 18. So we get the point 0, 18 as our y-intercept. Now we have 2 points. We have our vertex, and we have our y-intercept. But we need, at a minimum, 3 points. I'm leaving some space right here. I'm going to write a little sentence explanation thing in a minute, but I'm going to start making the graph first. So let's start making the graph. Let's see what we've got so far. 0, 18, and -4, 2. All right, so this is a pretty top-heavy graph. So 0, 18 was our y-intercept. 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So 0, 18, here's our first point. Then we had a vertex, which was the -4, 2. So that was left 4, up 2. Should be right here, approximately. And like I said, if you want to put a little V somewhere denoting that that's the vertex, that can help you when you're doing this on scratch work. So what I'm saying is from there, the graph either points up or it has to point down. Now, if this point is here, clearly it can't point down, because if it pointed down, you would have to look something like this to eventually hit that point, and now it's no longer a parabola. That's a more generic polynomial. So we already know that this curve is basically going to do this on the right side. Again, kind of flatten. I can do a little better than that. Kind of flatten out as you get closer and closer to the vertex, like that. Again, this is not a vertical line. It does keep going up and right from there. So all we got is those 2 points, and you need 3. What do you do? Well, someone could just say, all right, well, let me find what this point is. They could do f of -3 equals question mark. Or they could do f of -2 equals question mark. Or they could do f of -5 equals question mark. Or they could do f of 12 if they really wanted to, but that would not be my suggestion. I would say to stay left of the vertex, but you don't have to, technically speaking. But that is not what I'm going to do. I mentioned earlier in step 5, let's scroll back to the instructions. Step 5, plot any additional points as needed. You need at least 3. Use symmetry if you're able to. So I've talked about that symmetry argument. Whereas if you have a point of a certain height that's not at the vertex and it's 3 or 4 or 5 away, you can just go from that axis of symmetry that many in the other direction, and boom, you get a point. So let's draw out the axis of symmetry. Again, I technically didn't ask for it. Maybe I do, maybe I don't. Here's your axis of symmetry. It's just a vertical line going through the vertex. This is our mirror for the problem. And this function isn't even or odd. I'm just saying that this is the axis of symmetry. Now, from the axis of symmetry, you've got this point here at a height of 18. It is 4 units away from the axis of symmetry, because this was a -4 and this is a 0. 1, 2, 3, 4. So by symmetry, what I'm saying is there is another point 4 units to the left of that mirror, which would be at -8. So if I go left 4, 1, 2, 3, 4, boom, there's another point. There's your third point. Literally no algebra or arithmetic to do. Go, it's the best I can do there. I will write down what I just said in a second. But all I did was, since that was a 4, this has to be 4 away from the mirror as well. It's a fairly simple argument to make. I want to erase that little red dot. Wow, that was somehow worked. I don't even know what I did. All right, so by symmetry, just abbreviating the word symmetry, 0, 18, that original point, the y-intercept, is 4 units from the axis of symmetry, AOS axis of symmetry. So that says -8, why did I write 4? -8, 18 must be a point. And by the way, the axis of symmetry, the specific equation, is x equals, that vertex was at -4 for an x value, so the axis of symmetry is x equals -4. That's the vertical line, the vertical dotted line. Things that are in vertex form are easier to deal with as long as you know the patterns. As long as you remember, for the vertex, you take the opposite value here, and you take the same value here. And remember, you can always plug things in and try them out. Oh, this is -4, 2. So if I plug in -4, I expect the answer to be +2. And if you put a -4 here, this is all going to be 0. 0 squared is 0, plus 2 is 2. So it works. That's a good sign. So if I thought my vertex was at +4, 2, if I mess that up, if I put a 4 here, 4 plus 4 is 8, 8 squared is 64, 64 plus 2 is 66, that is definitely not 2. So you can take the time to do these little researches and checks and all that stuff to make sure that things are okay, as long as you have the time. All right, still not ready for these notes. So you go away. So again, there was your answer. Maybe my math lab asks for the axis of symmetry to be typed up and drawn. Maybe it doesn't. You must pay attention to the instructions. If you give it too much information, it's going to mark you wrong. If it asks for it and you don't graph it, it's going to mark it wrong. Again, on homework, I'm not going to give any fudge points for that. But on a test, if you showed your work and you emailed me about it, I could say, okay, well, here's some of the points for it. 4 to 5 points, because all you did was you gave me the axis of symmetry, or maybe 4.5 points out of 5, something like that. I don't know. But definitely generous as long as everything else was correct. You would lose more points for not doing the axis if it asked for it versus giving it to me if it didn't. And if I'm in a good mood, I might even say, I'm not going to take off for drawing the axis, but I need to be in a really good mood. All right. So that is the vertex form. Vertex form is really, really helpful because you can immediately just look at this thing and say, boom, vertex. The y-intercept is usually pretty easy to figure out. The x-intercept can be a pain, but finding them is a skill that you were supposed to have developed back in chapter 1, so hopefully you haven't lost that skill yet. When we're in what we call the general form, I did type up the axis symmetry stuff, right? Yes, I did. Good. Just making sure. So now we're going to talk about what we call the general form. So standard form was what I also called vertex form. General form doesn't have another name. General form of a parabola is just f of x equals ax squared plus bx plus c, where a, b, and c are numbers. But it's kind of nice to know it's the exact same, that looks like sane, A as before. The A in general form is the same A as in standard form, so that A still tells you whether you point up or down. It also tells you how wide or narrow it is, but we're not needing to really get into that because we're getting other points to figure that out. But it is an alternative way to graph parabolas. So here A, B, and C are numbers. Whoop-de-doo. In the last problem, we called them H and K, and we said the H and the K gave us a vertex, which is literally the most important of a quadratic. There's no number up here just telling me, oh, well, that's the vertex. So the general form is a little more annoying to look at it because there's no really good, juicy information screaming at us. But that's not to say we can't find it. We can't find that juicy information. So in this form, how can we find the vertex? The vertex, well, one method is to complete the square on this thing. You take your ax squared plus bx plus c, and you complete the square on ax squared plus bx. And then you would say, oh, well, I add that to both sides. Well, unfortunately, since this is an f of x equals the function, you can't add another number to that side, so you actually have to add and subtract it to the same side. With that a, you can't just divide it out, so that thing might get multiplied by the a. It's extremely confusing. I do not feel that we should be teaching it in Pre-Calc 1 in a little 10-minute session. So all that stuff I just said, I would suggest that you ignore me. Now, if you are advanced and can learn that and operate that way on your own, go for it. It's an awesome method. But what I'm going to give you instead is a formula. For your vertex, the h, which is the x coordinate of the vertex, is equal to negative b over 2a. That's it. That's the x coordinate of the vertex. And then the y coordinate, which we call k, you just plug in the x coordinate. That's all that says. Don't let this confuse you. K is f of h. What in the heck are you talking about? All that says is plug in the x value. That's all it says. To find the y value, plug in the x value. That's literally nothing new. So that's how we find our vertex. Still h comma k. Use a teeny little simple formula to find the h. And then you plug it in to find the k. Now there are textbooks and teachers that teach a formula for k. It's ugly. It's horrible. You don't want to memorize it. You don't want to use it. I don't suggest anyone use it. It is much easier to plug it in, and conceptually it makes sense. If you have an x value, you find a y by plugging it in. I want to remind you of something. I'm going to remind you of what the quadratic formula was. It was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this thing inside of the square root before we called the discriminant. So we said, oh, that's pretty sweet. The quadratic formula actually gives us two formulas. And we just referenced this discriminant earlier, talking about the number of x-intercepts, whether it's 2, 1, or 0, based on that being positive, 0, or negative. And it all makes sense based on how square roots work. Square roots of positives, you'll be adding and subtracting a different number, which is why there's 2. The square root of 0 is 0, so the plus or minus just goes away, and there's only 1. If you have a square root of a negative, that pulls out an I, and you can't imaginarily cross an axis, so you just don't cross the axis. But look at this, negative b over 2a, the other portion of that, that's the same thing as this. So the quadratic formula is a 3-fer. It's a 3-for-1. It gives you the formula for the solutions or the roots or the x-intercepts. That's all the same thing of a quadratic. It gives you a way to tell how many times you cross the x-axis, and it also gives you a way of determining the x value of the vertex. Some people prefer things in in general form, because then they just go negative b over 2a, negative b over 2a, negative b over 2a. Some people prefer things in vertex form, me personally, because, oh, the vertex is screaming at you in the face. You don't have to do any kind of formula for it. You just have to remember that whole this is opposite and this is not. If you're really, 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 really good at one and not the other, then you could learn how to go from one form to the other. You could go from vertex form to this new one by just foiling and distributing and combining. But to go from the ax squared plus bx plus c form to the other one, you'd have to do that completing the square jazz or know the formula. And I'm saying know the formula. It's much, much, much easier. 9 minutes. Oh, I really wish a wasn't a fraction. It's frustrating. I'm trying to figure out if I have enough time, and I know me sitting here not talking is wasting time. Let's try it. We gotta try. We gotta try. I'm not gonna cut class that early. We should be able to fit it there. So example 2, graph. Then for a, we're gonna have f of x is equal to x squared minus 5x plus 6. Now, some people like to go ahead and identify what your a's, b's, and c's are. That's up to you. I do, so your a is positive 1, your b is negative 5, and your c is 6. This is not in vertex form. I cannot just spit out the vertex immediately and say it's negative 5, 6. That's completely wrong. Neither of those is true. So to find the h, which is the x coordinate of your vertex, that would be the negative b over 2a. That's the formula, negative b over 2a. So take the b, which is negative 5, which makes it a double negative, over 2a, which is 2 times 1, which is positive 5 over 2. That is the x coordinate of the vertex. Excuse me. That's the h. The k we find by plugging in what we just found. We just plug that in for the x's. That's all we do. Don't overthink it. Now, you're going to get annoyed because this is a fraction we're plugging in, so that's 5/2 squared minus 5 times 5/2. I didn't need a parentheses, but I did it anyways. Then a plus 6. Oh boy, we got fraction math to do, don't we? So that k is equal to 25 over 4 minus 25 over 2 plus 6. You'll need to get an LCD. I'm not here to teach that. You've got to remember how to do that. With denominators of 1, 2, and 4, it's 4. So the k will be 25 over 4 minus, your new denominator is going to be a 4. 2 goes into 4 twice. 2 times 25 is 50. Then plus, that's 6 over 1 originally if you need to see that. 1 goes into 4 4 times. 4 times 6 is 24. So 24 over 4. 25 minus 50 is negative 25. Negative 25 plus 24 is negative 1. So we get negative 1/4 as the y value. It is completely unacceptable to not be able to handle fractions in this class. Do 100 of them if you have to. Put in the time and effort. If you can't do it now and you think you can't do it 100 later, trust me, you can. Just like lifting weights. The more you lift, the better you get, the stronger you get, the more you can lift, the more you can lift, the more you can lift. So that says our vertex is annoyingly 5/2 comma negative 1/4. To find our x-intercepts, intercepts, whatever. Oh, and by the way, since the a was positive, it opens up. I forgot to mention that earlier. So our x-intercepts, this is where we set the function equal to 0. Now, there's no parentheses squared this time, so I'm not going to do any plus or minus square roots. You're going to factor or do the quadratic formula. This is pretty easy to factor. Factors of 6 that add to 5 are 2 and 3, not 1 and 6. That would subtract to 5. Know your sign arithmetic, know how factoring works. So I got to go x2, x3. To make sure they add to a negative, they both need to be negative. Set each of those equal to 0 using your 0 product rule. Add 2, add 3, and you get x equals 2 and x equals 3. which means our X-intercepts are not 2, 3, it's 2, 0, and 3, 0. Y-intercepts, I'm just changing colors to fit this in here. That's when we do f of 0. This will be ridiculously easy. Here's our function. So we go 0 squared minus 5 times 0 plus 6, which I hope is very obvious that it's 6. All the 0 stuff just goes away. So if f of 0 is equal to 6, that makes the y-intercept 0, 6. We have 4 points to plot. We're going to do that really quickly, and then we're going to call it a day. Just kind of scroll out a little for now so we can see all the information. They're mainly on the right side. So 1, 2, 3. Then the y-intercept was 0, 6. 1, 2, 3, 4, 5, 6. Those 2, 0 and 3, 0 is right there. 0, 6 is right here. I haven't plotted the vertex yet. That was the fraction one, so I saved it for last. There it is. 5/2, negative 1/4, which, by the way, 5/2 is the same thing as 2.5. It might just help you be able to figure out where that is. So 5/2, negative 1/4. That's what we're plotting. So right 2.5 and down 1/4. So if this is down 1, I'm going to go right 2.5 and then down just barely. And those points are a little too gigantic now that I've zoomed back in. There we go, much better looking. So right 2.5 and then down 1/4 of the way. There's our vertex. And we can just connect, make our nice standard looking parabola shape, keep going, keep going, keep going. Boom. If we need the axis of symmetry, it would be a vertical dotted line going through that point there, and that AOS would be x is equal to 5/2. So that's the difference of graphing in one form versus the other. The vertex is not staring you in the face. You just calculate it based on a simple formula and plugging in a value. There's nothing too complicated to get that. I actually think the intercepts are easier to find in this form. So it's kind of funny. One form, the intercepts are easier to find. The other, it's the vertex that's easier to find. So you can't always have your cake and eat it too. We are not finished with 3.1. We will finish that next class. So again, focus on chapter 2 stuff for now, finishing the homework 2728, studying for the test. Review materials are available. Test is Wednesday and
Again, ignore that last part if you heard it. I thought I clipped my videos a little better, and apparently I didn't. So again, our test is Monday and Tuesday, the 29th and 30th. So we've already talked about that in great detail. Per usual, if you have any questions, please email me. Again, apologies for missing that little bit in the middle. But yeah, besides that, have a good weekend, study hard, work on those reviews. Remember, the reviews are great study resources for the test. And as always, again, if you have any questions, please shoot me an email. Take care, everybody.